Hello, everybody. Welcome to this small episode on a C# trick we're having to do with pattern matching. Essentially, it's a small trick illustrating that sometimes it's better not to write the pattern matching yourself, but instead having the runtime doing the pattern matching. So let's dive into some code. What we have here is that we have a list of mixed objects given to us by some presumably bad guy of some kind. It's really a list of objects, but the runtime objects are mixed in the sense that we have a bool here, we have an integer here, we have a string here, and we have a double here, and of course they will all fit into the list of object because that's allowed by the type system. But if we need to do type-specific processing for each of these types, we have to in some way figure out what the runtime type is, and then hit the correct handling method somewhere else. So let's assume we have this object handler here with a number of different handling methods. So it has a handle of bool, taking care of the specific handling for bools in particular. Let's assume we also have a handle of int and handle of double and handle of string and so on. Each in turn taking care of the type-specific handling for that particular type. So we have 4 overloads: handle of bool, handle of int, handle of double, and handle of string. And what we want to do is we want to make sure that whichever type we encounter in the list, that will be O in our traversal here, would be handled by an object handler of the correct method. So we just say object handler of O. The problem is the runtime would say, well, O here is an object, so there is no overload inside of object handler handling and handling the object type. We have one for bool, we have one for all other overloads, but I don't know which one to choose at runtime, so you have to do something about it. So what you might resort to is that you do know the switch, right? Everybody's favorite weapon now that we're in C# 7 and onwards. We have this pattern matching on types. So what we could do is we might resort to say, well, if this guy is actually a bool, let me go ahead and call the object handler. Well, let's call that particular bool overload, because now we know that if B is a bool, we'll just call the handle method being now we know that it's a correct overload, because now we know that it is in fact a bool what we're considering at runtime here. So if we do this, we will eventually end up with something like this, and it hurts a little bit inside, right? So, but it turns out that it might actually work. So for each of the types we have, strings, doubles, bools, and integers, let's just channel the call to the correct underlying handler type here. So if we run this program, what we will indeed get is that, well, we're calling the bool handling method for the bool. We're calling the integer handling for the method, and so for the integer and so on. But what we have, the problem we have is now if somebody tries to put in some sort of arbitrary object in here, we need to put in another handler method in here, and we also need to maybe put another case in here. That's not really nice. So the problem is, of course, we need to figure out which one to call at runtime, right? But what we would essentially want is to say, well, instead of me checking if it's some specific type and then calling that specific handler in 4 different cases, what we would ideally like is the runtime to make this pattern matching for us. So what we would want is to say, well, dear Mr. Runtime, I would like you to check get the best overload that you know for this one. So essentially, if I present you with an O, it's just an object, I don't know what it is, but at runtime, figure out what the runtime type is and try to find the best possible overload. The only thing is, you have to apply a small trick in order for this to work. So what you actually want is you want dynamic dispatch. So instead of pattern matching a static type and then mapping it to a specific static overload, what you would do is you will say, well, let me have the runtime do the pattern matching, because that means if I put dynamic here, it says, well, then the runtime will say, I don't know which one it is right now at compile time, so I can't really give you any errors, I can't really give you any help of any kind, but the runtime will decide which overloads to present. So if I say handle of O, what happens is that, well, it will try at runtime to figure out what is the best handling method available, and if there are none, then we'll get an error. So, but let's just run the program and see what happens, and we'll actually see, we'll get the very same experience that we got from doing the pattern matching ourselves. Only now we are doing nothing of the sorts explicitly, but we're doing it implicitly via the runtime. So of course that poses a question: what happens if somebody puts in some sort of crazy type like some anonymous type saying here's a point of some kind. Let's do some kind of point here. So let's assume we have this. Then we're pretty sure it wouldn't really hit any of these handling methods that we have here. So what will happen is that, of course, the dynamic dispatch would fail. So we'll say, well, sorry about that. But the best overload I can find is actually has some invalid arguments. I cannot really match this one up against any of the predefined ones here. But what we could do is we could do like a default case saying, well, let's do one for object. And that means if we find one which is really not any of these, at least it should be an object, right? Because any type is convertible to an object implicitly. So if we do this our point type, our anonymous point type, we just go into this very last clause here, and what you will see is it will just say, well, I am handling some objects. Don't know what it is, but it's at least an object. And the good thing about this is I don't really have to change anything in my code here, so it still figures out the best way to do these kind of things. So the essential part here is, instead of us doing the pattern matching and then mapping it to the correct methods, why don't we let the runtime do that particular thing for us? Thank you very much for your time. If you think that this is a nice trick, let's do some more tricks together, and in the future keep an eye on the YouTube channel, and do let me know in the comments if there is any kind of funny thing that we should discuss.